Okay, I hope I'm audible to all students who are attending this lecture of statistical methods for economics. In this particular lecture, we continue with our discussion of elementary probability theory. This is a very important module I cover up in my lectures on statistical methods for economics. If all students can recall that we had started our discussion of this particular module in the previous lecture, okay? The books I prefer to follow as reference for my lectures on this particular module. This is Probability for Statistics and Engineers by J.L. Devor. Fundamentals of Statistics by S.C. Gupta. That's the practice book I prefer to follow. And Statistics for Business and Economics by Alan Webster. These are three main books, and along with this I also prefer to follow several other books also for practice. Access will be given to all concerned students for those books. Now students can recall that in the previous lecture we had looked at some important terminologies involved in our probability theory lectures. We had looked at the concept of what is meant by an experiment, what is meant by a sample space. We had also looked at some numerical examples on calculating the sample space of an experiment. We had also looked at what is the definition of an event. An event is nothing but a subset of the sample space. And we had also looked at the type of events. We had looked at the simple event, which contains only one outcome from the sample space, and compound event, which contains more than one outcome from the sample space. And we had done some good numerical practice also in the previous lecture. Now, in this particular lecture, we continue with probability theory, and we now look at some relations from set theory. So students can write the heading Relations from Set Theory. Relations from set theory. Before jumping on to some useful axioms for probability, we are now going to first of all from set theory look at what is meant by a complement of an event, what is meant by union of two events, intersection of two events, and so on. Okay, so students can write the first point, complement of an event. Complement of an event. So I can write that the complement of an event A. Remember, event A is a subset of the sample space. So I can write in the bracket subset of the sample space. The symbol I use to denote the sample space is delta. The complement of an event A denoted by A dash or A complement is the set of all outcomes, is the set of all the outcomes in the sample space delta that are not contained in A. That are not contained in A. So when I look at A complement will contain all those events which lie in the sample space but which do not lie in A. Okay, a Venn diagram makes it even more clear. Remember, in set theory, we always represent sets using Venn diagrams. Now we are representing events using Venn diagrams. So suppose this is my whole sample space, delta, which contains set of all possible outcomes. And suppose I have an event A, which is a subset of delta. You can see that the event A lies within the sample space delta. So this is my sample space. And A is an event. Okay, now what is A complement? A complement is are containing all those events which lie in delta but not in A. If I shade them, basically all this red shaded area, all this red shaded area is going to contain outcomes which lie in the sample space but which do not lie in A. So the red shaded area, I can call it as A complement. The red shaded area is called the A complement. Okay, so you can clearly see that this is called A complement or A dash. Set of all those outcomes which lie in the sample space but which do not lie in A, outside A. Okay, then let's look at the second relation. So for this, I'm erasing all this off. Second relation, union of two events. Union of two events. So I can write that the union of two events, the union of two events A and B, denoted by A union B, is the event consisting of all the outcomes that are either in A or in B or in both the events A and B. So I can say, therefore, A union B contains all the outcomes lying in at least one of the events. So wherever you see the word at least one, wherever you see this, it means union of two events. So I'm explaining this again, students. When I say union of two events A and B, it is denoted by A union B. It contains all those outcomes which lie either in A or in B or in both. These events lie either in A or in B or in both. That is given by A union. Okay, so if I draw a Venn diagram, to show union, again, this is my sample space, delta. Okay, this is event A, this is event B. Suppose both of them are also intersecting each other. So when I say A union B, set of events which are there in A also, which are there in B also, and which are there in both A and B. So this all the red shaded area is A union. This is A union. Set of all those events which are there in either A or B or both. Okay, so this is the diagram for A union B. I can also call it as A or B, because remember, union, U denotes union, and union also means or. Or I can also call it as at least one. So if I ask all students, what are the set of outcomes which lie in at least A or B? It means nothing but A union B. Okay, so I hope students have understood this. Let's now look at the next set of events. So if I write the third relation, intersection. So I can write that the intersection of two events A and B, denoted by A intersection B, is the event consisting of all the outcomes that are there in both A and B. So intersection means I'm specifically looking at those events which lie in both A and B. Union was where the events were lying either in A or in B or in both. Intersection is only the last case where the events lie in both A and B. So again, a Venn diagram makes it more clear. A Venn diagram makes it even more clear. Again, I draw the sample space, which is delta. This is event A. This is event B. Now, what are the outcomes which lie purely in both A and B? It's nothing but this area. Students can look at the shaded red area. It contains the outcomes which lie in A also, and they lie in B also. So this is called A intersection. So I can read A intersection B also as A and B. So students should be able to understand the difference between A union B and A and intersection B. So I'm rewriting it again. A union B means A or B, which I can write set of events that lie either in A or in B or in both. This is a sum up. A intersection B, also called A and B, is the set of events that lie in A and B, that lie in both A and B, that lie in both A and B. So this is the union of two events. This is the intersection of two events. Okay. So I hope that all students have understood this. And then let's look at numerical example to calculate, intersection and, unions and all. So erasing all this off, let's look at a numerical example. A numerical example. So let the sample space be given by the set 0, 1, 2, 3, 4, 5, 6. Suppose this is my sample space. Let the event A be containing the elements 0, 1, 2, 3, 4. Suppose event B contains the elements 3, 4, 5, 6. And event C contains the elements 1, 3, and 5. Okay, the question asks us to find A complement, A union B, A union C, A intersection B, A intersection C, A intersection C complement. How do I find A complement? Very simple. From the sample space, subtract the elements of A. So the sample space is 0, 1, 2, 3, 4, 5, 6. From this, you subtract all the elements of A. The elements of A are 0, 1, 2, 3. So from 0, 1, 2, 3, 4, 5, 6, if I subtract 0, 1, 2, 3, 4, what do I get? 5 and 6. This is how we do the difference between two sets. Again, students should have some basic knowledge of set theory, how to add and subtract sets. A union B is nothing but I just simply take all the elements of A and B together and I write them. So A union B is 0, 1, 2, 3, 4, 5, 6. Now students should know, even though 3, 4 is coming here, 3, 4 is coming here, I will write it only once. I will not write it twice. Remember, A union B means you just add up all the elements of A and B and you write them together in a set. Very simple. Because A union B simply means all those elements which are either in A or in B or in both. So in both A and B, 3, 4 is repeated, but I'll write 3, 4 only once. I'll not write it again because 3, 4 are the common elements in both A and B. What is A union C? 0, 1, 2, 3, 4. This is my A. C is 1, 3, 5. Just write all the elements together. So 0, 1, 2, 3, 4, 5. This is A union C. What is A intersection B? Now A is 0, 1, 2, 3, 4. B is 3, 4, 5, 6. Now A intersection B means only those elements which are common in A and B. 3 is common in both. 4 is common in both. So my answer is 3, 4. When you look at intersection, you only look at the elements which are common in both. When you look at union, you simply write all the elements of the two sets together without repeating them again. Okay. What is A intersection C? Now A is 0, 1, 2, 3, 4 and C is 1, 3, 5. Now what are the elements which are common to both A and C? 1 is there in both, 3 is there in both. So my answer is 1, 3. This is A intersection C. How do I find A intersection C complement? Whenever you have to find complement, you just subtract the set from the sample space. The sample space is delta. From delta, subtract A intersection C. You will get A intersection C complement. Whenever you have to find the complement of any set, you subtract that set from the sample space or from the universal set. The sample space is also called the universal set. It contains all possible elements. Now delta is 0, 1, 2, 3, 4, 5, 6. A intersection C from part 5, I've already calculated, which came out as 1, 3. Now from this, if I subtract 1 and 3, what do I get? 0, 2, 4, 5, 6. This is A intersection C complement. Okay, so I stop in this particular lecture. It was a short lecture where we looked at some of the relations from set theory in defining events. We have looked at the complement of an event, union of two events, intersection of two events, and we have done a practice numerical based on this. Now, in the next lecture, we are going to look at mutually exclusive and exhaustive events. We are going to look at mutually exclusive and exhaustive events in the next lecture, along with some axioms on probability. All this I am going to cover up in the next lecture. I stop in this lecture. I hope students have enjoyed this lecture. Any doubts, you can unmute your mic and ask, or you can get in touch with me for doubts on call or WhatsApp, or you can mail me your doubts at divineschoolofeconomics@gmail.com. This is where I stop in this lecture.